This content is brought to you by BEC Financial Technologies, developing and operating IT for Danish banks.
Here we go. Jeszcze raz. Robert Pasiński.
Hi. I just want to say that I'm really excited to be here because I first heard about WarsawJS when I was looking for some issue, and I found out that you have a very big and large content in your YouTube channel. So I've actually watched quite a few presentations, and yeah, I'm really excited to be here because if I got it correctly, you are like the longest living meetup in Poland regarding the JavaScript, so that's quite a feat.
Almost 6,000 members, yes.
Yeah, that's cool. Yeah, so today I want to talk about deep diving into JavaScript task scheduling, but I realized it's very hard to do in 20 to 23 minutes. Actually, it's impossible. So I've decided to split the knowledge into the information that can be helpful to the beginners in JavaScript, and maybe some smaller feats and information that can be helpful for experts who maybe don't know some parts from the specification. So yeah, what I'll be talking today about is quickly mention about available specifications and where to look for them and what is where, because it's not that obvious. The second part will be, we'll go quickly through the task and promises and how are they processed and how they are different. And then we'll quickly go through the job processing in JavaScript engines. There's a lot of information in these sections already, so I will not go that much into detail as I would want to, but nevertheless, there will be some helpful information, I believe. And then we'll talk about background tasks. So how can we offload the logic and the operations from to make our application more responsive? Lastly, we'll mention all available APIs that we can use to leverage all the possible interfaces that different runtimes give us. So quickly about myself. I'm senior software engineer at CallStack, and I'm working on, let's say, open source department. I'm contributing to React Native and Hermes, which is the JavaScript interpreter behind React Native. So it's like kind of V8 and browser part. So my current work is actually to bring the web APIs to React Native. So the gap between React Native and web APIs is much closer. And yeah, that's all I can say about me. And I would like to start with a, let's say, simple but I think quite popular quiz regarding how this code would be executed. And I want to ask you, what do you believe is the correct answer? So maybe let's raise your hand if you believe the output of this code would be 1, 2, 3. So that's the answer A. If you believe this is the answer, raise your hand. Don't be shy. Okay, no one believes that it's 1, 2, 3. Who believes that this code would print out 3 to 1? Okay, we have quite some hands. All right. And who would believe that this code would print out 3, 1, 2? Okay, so I think it's like 50-50. And the correct answer is 3 to 1, and we'll talk about why in a moment. But it's not really that there's only one correct answer, because if we're talking about HTML, the correct answer is 3 to 1 because of the constraints and the, let's say, steps that the HTML specification requires. But when we are talking about ECMAScript, so the specification behind JavaScript, there are 2 correct answers because it can be either 312 or 321. And we'll also talk about why and what happens so that there's 2 possible options. And yeah, so let's quickly go through the specifications. It's not that obvious, believe me. So yeah, that's I think the okay. So there is the main, let's say, phrase event loop. I think most of us heard it, like reading some material, watching some tutorials, or just heard it while you're working with JavaScript. But in reality, there are many more different terms that are related to task scheduling. Sorry for the broken layout, but it seems that the font is missing, so that causes the distortion. And yeah, you can lose your mind while reading all of them. And specification, because there are many of them, like they are very eager to use all of them instead of naming things easily. So yeah, well, we have event loop on one side, which I guess, all heard of, and we have ECMAScript. And during this presentation, I want to highlight that the event loop does not exist in ECMAScript specification. It's very important to distinguish this because you have specification of ECMAScript, which we will talk about in a second, which provides some constraints on language, like how promises are executed, what are the promises, different instructions and statements. So the goal of ECMAScript is to be the standard. So it's the main one for all languages that implement ECMAScript. And the intention behind it is to be pretty abstract. So they are trying to define the common ground of different languages that implement ECMAScript, but they leave quite a room for other implementers to adjust the behavior, but in an expected manner. Yeah, what I said, that there are many implementations of ECMAScripts. The obvious one is the JavaScript that most of us are working with. But there was, quite some time ago, there was this action script, which was used in Flash Player. It was a variant of ECMAScript. It mostly was working the same as JavaScript if you had some experience working with it. But there were some quirks. Also, there is like Qt script, which is a implementation of ECMAScript, but it's like a variant of it that's used in a Qt framework that's used in C++. It's mostly used like for different UI applications across different platforms, and it's gaining traction in automotive sector. So that's it. And lastly, but there are actually more of them. One of the examples is like Google Apps Script, which is the variant of ECMAScript that you can use to extend the Google Docs applications like Docs or Slides. So you can create your own commands using this Google Apps Script, and you can create new features. And on top of that, in a different specifications, we have HTML and DOM. So this specification is mostly targeted towards browsers. So it defines mostly how browser interacts with JavaScript and how it should run, essentially. Yeah, it builds on top of ECMAScript standard. So it takes the abstract part of ECMAScript and implements it in a compatible manner, which we'll talk about. And yeah, there are two standards. One is W3C and another one is WWG. There was some diss between them, but lastly I've checked, they come to a conclusion, and whenever you go, you can find the latest version, which is the living standard, because HTML standard is no longer versioned as it was. Yeah, and to illustrate the difference, we see a browser on the left side, which obviously has a big yellow part of JavaScript, and you can see different smaller APIs that the browser provides. And actually, looking at it, I should highlight event loop as well, because event loop is core of all of those APIs, because every other API builds on top of event loop. Another runtime we can distinguish is Node.js, which notably misses the DOM part. But obviously, there is no DOM in Node.js, but they are also taking some parts from browser that were part of the HTML standard and implemented to be more compatible. So we can have like Tamer APIs and others that are not required by ECMAScript, but they were added for convenience and to create a bigger compatibility platform. Also, there is another runtime, which is React Native. Similar to Node.js, it's not really a browser environment, but there's some effort currently ongoing to create a native implementation of the missing APIs. So soon you will be able to have a DOM API in new React Native. So it will bring all the, actually not whole DOM because it's quite a challenge to re-implement the browser, but standard HTML components will be available, such as aside div and such, and obviously CSS to style the components. The same goes with Tamer APIs. For quite a long time they were polyfilled, but there is an ongoing effort to bring them to the native implementation. Yeah, that was all about specifications. Let's talk about task queues. On the left side, we can see a pretty simple snippet. We define a single function on top of it, and we invoke it in 3 different manners. So I will skip the part where we go through the interpretation of the first function, but we want to visualize how this code is executed. So first of all, the JavaScript interpreter, after finding the function bar, goes to line 5 and invokes the bar function. And what happens next is, we got the output on the bottom. What happens next is we go into the function of the body. And to represent this in some concepts, we bring in the call stack, which is actually it should grow from bottom to up, but for the sake of what I'm going to present later on, I've decided to make it horizontal. It grows from left to right, but call stack represents what chain of the function execution we are in. So because we were invoked by line 5, we get the bar function on the call stack, and we know that we are called and from where and all the information related to the function is captured. And we get the foo in the output. Next, we are going to line 6 because we ended the evaluation of bar function, and we are going to line 6, which is promise resolve then bar. And what this does actually is to represent it, we need to introduce another concept, which is the microtask queue. And microtask queue is a kind of specific one. I will talk about it later. But we are not executing this function immediately. We are just scheduling its execution. And later on, lastly, we are calling the set timeout, the same function, but with argument 0. And what it does, it schedules this execution of this function on the macro task queue. So it's 2 different task queues. And the fact that the bar function was scheduled on the macro task queue immediately is the case because we passed 0. If we introduce any kind of timeout, the function would not be immediately on the queue, but would be added after some timeout. Yeah, and we finish the execution of this script, and in the specification it's called script normal completion. So if you ever go read the ECMAScript specification, they call it completion. It's either success or failure completion. And yeah, this is the script that we got executed by the browser. And in the specification, the tasks are called jobs, and the task queues are called job queue. So you can treat a job like an abstract task, which is implemented by the browser. What happens next is the browser picks a scheduled task from microtask queue and executes it. But as you can see, I intentionally changed the source code of it because we are not actually running the same function bar. We are in a different context. And as you can see, the call stack is empty, and that's important because we were executed and invoked by the scheduler. So the context of it is different, and it's very important to remember. And what happens here, I just highlight that the function changed, the body of source code changed, and the only instruction here is the console log. So obviously that's invoked, and we get it on the output, as you can see. And the invocation of this task is completed. So there's another success normal completion of the script. And right now, the event loop is doing nothing. It's waiting. This is a single, let's say, tick of a event loop. It does some things right now, which we'll discuss later, and it restarts. So when it starts again, it looks at the first task from the macro task queue, and it picks it, the same source code. We invoke the console log. It's printed out, and that's it. And another successful completion. And if we want to represent what we already seen about the event loop, we can show it like this. So the event loop is doing infinitely as long as it exists. We invoke the single macro task from the top, usually the oldest one, and then we execute a micro task, but in a different manner. We are draining the micro tasks, so we are executing them as long as there's any micro task to be done, and we'll show it later on. There is a function in HTML. It's not part of the ECMAScript standard, hence the logo on the right. It actually does the same as promise resolve then. It queues a function that's passed as a parameter at the end of microtask queue. It can be used in workers. It's queued once and then it's removed from the queue. So if you want it to be executed all the time, you have to reinvoke it recursively, and it cannot be canceled. So if you queued a microtask, you cannot cancel it by global and provided functions. And let's talk about how these jobs or tasks in HTML terminology are processed. So this is a snippet from the ECMAScript specification. It's part of the job processing section. So ECMAScript requires that only one job or task may be actively undergoing evaluation at any point in time. So there is no stopping of the task. It has to be started from the beginning to end, as the second point says. So it moves around to the completion, which is just saying that it should finish. And the abstract closure, that is actually a function of our script, so it's just a piece of code that to be executed, must return a normal completion. So that's why I mentioned the call stack, because it has to be successful. And job queues, this is also the part from the specification. Host environments, so any kind of JavaScript runtime, such as browser, Node.js or React Native, is not required to treat jobs uniformly. And that's what it does. And there's even a part in the example that says that Node.js and browsers treat promised jobs higher than others. So the drain microtask part was not part of ECMA specification. It's part of HTML specification. So it's not guaranteed to be in every runtime that supports ECMAScript. This is the part that HTML provides us, not the ECMAScript. And let's quickly talk about ECMAScript. HTML task queues. HTML defines different kind of task queues. It's actually up to the implementer, like the browser, to split the task queues. But most common ones are DOM manipulation, user interaction, networking, navigation, rendering, and there can be as many task queues as the host wants. They are used mostly for scheduling and prioritization. So, for example, rendering takes the highest priority because you don't want the user to see the lags and the distortion by, for example, networking tasks. So they are having the higher priority. And one very, very important distinction is that microtask queue, so the promises, is not this kind of a queue. It's a very different one because it's treated very, very specially. And yeah, so here we have the example of macro task and microtasks. And this example illustrates that first we schedule a macro task, which prints C, and we have a promise that resolves immediately, prints A, and then returns another promise, which immediately resolves and prints B. And because the step of draining microtask is a loop, we can be sure that promise resolve all promises here, because they are already resolved, are executed first, and after all the micro tasks that were queued are executed, the macro task executes. So in this example, the output will be ABC, because if we get all the chain of resolved promises, they will be all first executed, and then anything else will be executed, but they have to be already resolved. If we did some kind of fetch here, it would be broken into macro task, because we are waiting for the response from the server. So we are waiting for the fetch, and the response is scheduled later on. And because the draining of micro tasks is a loop, we can explode it. So this is like an example of while zero, do nothing, in microtask example. So we are infinitely queuing microtask, and it can never be drained. So this causes the page to be unresponsive, and it can actually freeze your browser. It's not protected from it. And the most important, why should we care? So imagine this example. We are invoking fetch, and then calling then on it. And obviously, if you all were working with promises, you know it won't catch the error, because you should use catch. And you should use catch because it's a different call stack and a different context. So if we execute fetch, then, as mentioned, won't get executed, and catch would never be invoked, and the code goes on. So that's important to notice. While it's obvious, the same goes with macro tasks. You can, for example, schedule a macro task with an error, and it won't catch because it will be executed after this script died. So this script can be completed, it can be gone, and then the macro task invokes. And why it's important, consider this imaginary component from imaginary UI framework. So we have some kind of component. We have this only the load user function. And we are fetching the information about user and storing the response in a cache. And does any of you can highlight what's wrong with this code? Can any of you notice what's wrong with this code? It's not breaking part, but it can be surprising one when you go much into the details. So what's wrong with this code is that one part of the code is executed using microtasks. As you can see, let's just go through the invocation, and you can see that the then is scheduled on the microtask, and it's executed in completely different context. And when we cache is on, we are invoking it synchronously. So as you can see, we invoke user loaded in the same context. So if this ever thrown an exception, in this case, it wouldn't be propagated to the UI component. And in this case, if this function fails, it will blow the rendering part of the application. So the solution is to, let me just quickly skip to it. Yeah, this is the different, also the order of execution is different. So if you have any profiling, reporting, it's also different. So in first case, the render is last. In second part, the render is before last. I'm just finishing. I'm sprinting through the presentation right now. And the corrected code should look like this. So as you can see, we are wrapping the cached value in promise resolve to ensure that both cases of both branches of this function are invoked in the same manner. So both of the branches go to the microtask queue, and whenever branch is invoked, it behaves the same. So the order of functions is the same. As you can see, the same goes with the get user. And I think I just...
Robert Pasiński, everybody. Robert Pasiński.
Okay.
Really happy.
Yeah.
I appreciate when people ask questions. Here we go.
Hi, could you tell something about this slide?
Nice one. I think it speaks for itself. I don't want to break the system and, extend my time. So I'll just let you read it in peace. And yeah, and if you have any more questions, I'll just, maybe if you are interested, hit me up on Slack. I can send you the presentation if you're interested. And if you have any question that beyond the time frame, feel free to hit me up. And I'm not.
So how long are the specification for ECMAScript and HTML and all of that? Did you read all of that?
They are very long. If you have a lonely evening and you want to get lost in it, I don't recommend it because it's terrible. But if you like digging into details and like reading some weird stuff, then I honestly recommend it. You have lots of material to read. You won't get bored easily if you are into this stuff.
Do a Google search for 262 spec. That'll be a lot of fun. Okay, my question is, I came into it a little bit late, but I think I saw you had a slide that said that somebody with React Native was trying to implement basically all the DOM APIs and stuff like that? Okay, what would be, so for example, a benefit in using something like that, given that it's enormously complicated and very easy to get wrong to implement all those APIs, when there's something already like socket runtime that can run basically native apps using like just a regular JavaScript engine with all the APIs that have been implemented already for WebKit?
Yes, so the main goal of it is to actually make more code that is developed for web to be supported by React Native. It's very hard to do it right because if you wanted to implement the whole DOM API, you would have to re-implement the browser, essentially. So the goal is to close the gap, implement like some kind of JavaScript, CSS style sheet processing. So it's not that native yet, but it's kind of polyfold on a higher level, and some of the parts that are core are moved to native for better performance. But if you want 100% compatibility, you need a browser, essentially. So what it does is just to reduce the gap and make it easier to develop the apps. For example, if you want to go into the React Native for the first time, you can use divs, you can use asides, you can use styles, and while it's not native, you can feel like it's working, and that's the general idea.
Hi, thanks for the presentation. I would like to ask a follow-up question to this DOM thing. Will the shadow DOM spec and all the things about it be part of React Native, or is it out of scope?
From what I know, I only like partly work with it. I actually work on the bringing the scheduling work to the React Native. But for what I know is that the shadow DOM is actually not being worked on. The goal is to bring the simple code to the React Native and then progressively add more compatibility. So the shadow DOM is, I think, very deep into the specification and very light. So there are more important parts that needs to be moved to the React Native so that most of the code is working. Because if you had a shadow DOM on React Native, you could essentially run React Web on React Native because React runs on shadow DOM. And I think no. For now, maybe it could be bridged between the native views. I don't know, but I think it will be quite some time before we see Shadow DOM for React Native. Okay, so that's a thank you. And I want to invite Łukasz for stage for a moment.
Łukasz who?
Hudziński.
Hudziński! Łukasz Hudziński! One of my favorite guys from our call stack. Hey, Łukasz.
I'll be fast. So a lot of exciting questions about React Native and web compatibility and all of that. If you want to know more, we have a conference in 3 weeks in Wrocław. It's called React Universe Conf. This is actually the 8th time that we are doing the conference. Previously, it was known as React Native EU. So we broaden our scope to include more React and web-related topics to the conference. Yeah, so Robert will be there. I will be there, Michał will be there, and yeah. And all of those people will be there. You know, you definitely know Kent, you definitely know Evan Bacon and Dan Abramov and Delba. If you want to join us, we have a promo code for you, 15%. Conference is in 3 weeks in Wrocław, 5th and 6th of September, so feel invited. Thank you.